Good afternoon. So today we're going to have the second part of the paper entitled A Public Platform for Virtual IoT-base Monitoring and Tracking of Covid-19. The authors are as follows: Yunchan Jung and Ronel Agulto. For the third part, this will discuss the platform architecture with BOITs, CDC and SDNC. As we all know, one of the key ideas of this paper is to solve how all COVID-19 information providers operate with different secret keys. What are those providers? The platform participants are as follows: BOIT, CDC, and SDNC. And basically, as the ordinary users, or what we call as the information consumer. This platform actually consists of BOIT, which participates as an information provider, the CDC as well as to assist in maintaining a link between the BOIT and SDNC, while the SDNC will provide means to allow information consumers to receive information provided by information provider in real time. Again, the information provider here is the CDC. Now, what are the basics of this proposed security management? We all know that the privacy of personal information is really an essential factor in public platform. Each one of the users should assure that his information should be kept confidential. As an individual BOIT secret key is created and provided by its CDC, each BOIT node will use the secret key to update location-related information to the SDNC. Then, the SDNC will generate and use this secret key in real time whenever it receives its update. The SDNC has the security association information for each CDC to create those volume of the H keys which is requested by the CDC. Therefore, we can see here that the CDC can monitor the RR or the resources record information about the BOIT nodes under its control. Unlike the BOIT nodes, the ordinary user can only obtain limited information from the SDNC without using a secret key. Let's consider a scenario. Suppose the CDNC and SDNC is wish to exchange a group of keys. So here, the total number of secret key is equal to the number of people the CDC needs to manage. So it is a bulk of users that it needs to manage. So the CDC will select N, which is the random integer. That is then the secret value table, which can be represented by the following: XD1, XD2, up to XDN, and computes N, corresponding as the blind values, or the blind value table, which will be represented as YD of 1, YD of 2, up to YD of N, wherein YD of I can be computed using the formula alpha raised to XD of I mod Q, wherein I is equals to 1, 2, 3, up to N. So if we consider the DH or the Diffie-Hellman cryptography system, a set of global public elements which includes a large number as represented of our Q and alpha integer, which is what we call as the primitive roots of Q. By then, each of the CDC will use a set of different global parameter for the Diffie-Hellman key exchange. The secret key can be any value within the range I to Q minus 1. Assuming that the advanced encryption standard or the AES is used for the symmetric encryption algorithm, the size of the prime number Q needs to be as much as 128 bits. This range can accommodate large numbers of users on this particular cryptography system. Similarly, the SDNC independently will select N, random integer, that is the secret value table SVT, which then be represented as X of S1, X of S2, 2X of Sn. And then it will compute n corresponding with the blind value, that is the BBT, wherein the BBT or the blind value table can be calculated using the formula of y s of I is equals to alpha raised to x of s sub I mod q, again wherein I is equals to 1 to the range n. Each of those sides will keep the SBT private and makes the blind value table available publicly, which will then be disseminated through our network configuration. After the mutual exchange of the blind value tables, the CDC will compute the ith of the DH key, such as using the formula of the encryption. And then the SDN will compute the ith key as follows. These two calculations will produce identical results, or should produce identical results, using the DP-Hellman key exchange algorithm. Those all sensitive information handled by the SDN platform is encrypted with a DH secret key for the individual. This is clearly represented for the following algorithm. For the ith person, would the CDNC manage, the CDC and BOIT node of the person will use the private key, while the SDNC will use the public key for that person. For privacy purposes, both CDC and SDN platform manage COVID-19 related persons with only the identifier of the CDC side blind value, which is represented as YD of I for the specific person. Now, considering the platform structure based on the software-defined network controller. So the CDC here will manage a list of people who needs to be monitored related to the COVID-19, and it will possibly install BOIT nodes in the form of application on their smartphone. So each of the users here will possibly install the applications, which will then manage the list of people who will use this. Then a BOIT node can be confirmed case or a suspected infection, regardless of the privacy that the user and the network is currently. This is a social obligation to those who are controlled by the CDC. Even a large number of CDC can exist worldwide. Each of those CDC controls the BOIT node or a list of people who needs monitoring and tracking in its control range. So the CDC will manage and control everything, every information that the BOIT nodes handle. So if you look on this figure, for BOIT node, its wallets contains two parameters or two types of records: DSA or the Security Association, and the RR or the resource record. So what is the role of those two types of records or wallets? So basically, the SA or the Security Association record, which the CDC provides via offline transmission. So it contains the same content as the corresponding entry stored in the CDC's database or the CDC Security Association database or the SADB. So the size of the CDC's SADB will come to the total number of the people in its control or currently use the given platform, while the resource record or the RR in the BOIT wallet, which is always up to date, maintains consistency with the corresponding entries stored in what we call as the SDNC's RRDB. Okay? Then, SDNC is a centralized center that collects the resource record information from the distributed informations provider or the BOIT nodes under the distributed CDC's control. So basically, the CDC will control the given wallet, while each of the BOIT node is responsible for updating their own resource record in their database at SDNC An ordinary user can even reach the RRDB or Resource Record Database at the SDNC level and obtain the necessary resource record parameters except for the privacy related data, even though the user does not maintain any security association. Those privacy related data informations are stored in the MIDB or the medical information database in our system. So basically this figure will show two different BOIT as COVID related nodes, and the other one is the support node. Okay, now the BOIT may also operate differently from for support purposes. What are those instances? For example, one can take advantage of the BOIT support node in the area of a public transport. So going back on this figure, so we represent PT as the type under the public transport. So what are those categories? So those might be in the form of public transport bus driver. So let's say, for example, the CDC will require public transport bus drivers to mount BOIT nodes on either driver's smartphone and establish security relationship in the same way as the COVID-related BOIT nodes. So basically, at the same time, the type field value of the resource record here or the data is PT or the public transport. Then, whenever the driver drives the bus and changes its location, so basically the platform should correspond on the change of this location. So his location information will then be reported to the SDNC. Then, in an instances, if a passenger traveling by a bus wants to know whether the COVID-related person is within his area or is on the bus, or he or she is riding same way with the COVID-related person, they will send the query to the SDNC. So if there is a COVID person on the bus, the SDNC will let the ordinary user or the passenger know about this. So if there is no COVID person on the board, supposedly, the SDNC will also respond to the situation, telling that, of course, there's no specific passenger which is, let's say, for example, infected with the COVID. And then, suppose the SDNC can search for the RR or the resource record entries that also change in the same pattern as the driver's position information. So in that case, it will allow the passenger to see in real time the COVID-related situation in a certain moving vehicle. So basically, the task performed by the BOIT wallet software will include the following. First, get an SA from its CDC and install it. The CDC is responsible for its revocation. Okay? Then, this BOIT wallet software can also track its location-related status. What are those parameters? So it might include current IP addresses and GPS data when a person moves. So GPS is really important here to perform geolocation on our system. Also, the BOIT wallet is responsible to renew its resource record based on the change location-related status. So it should be in a real-time scenario. Then it will register the renewed resource record or the update on the system to the SDNC immediately if there is any change at the current location. So this is very crucial to implement because it should be in a form that when a bus move at a certain location and a person entered that bus, if there is a platform that are installed in their smartphone, they should be notified on that specific instance that you are in a place wherein there is a infected or related person, COVID-related persons. So, the CDC is usually normally in a country that is a national center for disease control and prevention. So, they are responsible in either mitigation and then controlling the effect of the COVID-19. Okay? So, as we going to indicate in other figure, the CDC maintains two type of databases. As was shown in the first figure, those two databases is the SA databases and the MIDB, or the medical information databases. So basically, the role of the one of these database is for security management, and the other is for managing medical information. So basically, the SADB here, each entry in an SA, or in this type of database, will contain security variables that enables both CDC and SDNC to compute the same key exchange for a certain BOIT. So basically, the task performed by the CDC software here will usually include the following. First, the CDC software can request to generate all SADB entries at a time to the SDNC. And SA contains DP-Hellman or DH parameters necessary to determine the resultant DH key. The key is applied to encrypt sensitive information in RRs, wherein the field value of the BOIT node ID as represented is the identifier, or it will identify each SA, or the security association here. It will also maintain SADB entries that tell which SA to use to apply to decipher an encrypted part of a given RR. So an SA specifies the same TH key applied between the CDC and SDNC, as well as the BOIT and SDNC. The field value of the BOIT node ID indicates a specific SA among the SADB entries. At the same time, the CDC software will also maintain the MIDB entries. So the MIDB entries are here. So the field value of the BOIT node, which will identify the medical status information related to a specific person in need of care. The CDC gives him or her, let's say the user, a unique management number, or the ID in case, and then classes it according to its severity. Each can also belong to a one confirmed cases. Let's say type here can be a form of C, or confirmed case group, an S, or a self-isolated group, and O for those who need observation. So you're expecting those value to be represented on this field. So the type classifies a specific group. So this field also includes PT, or the public transportation, just like the same on the given examples that we have a while ago. So this is to specify the BOIT support node. So let's say people with COVID-19 can experience, let's say, we all know that they can experience mild to severe respiratory illness. That field of medical information in this figure can explain COVID-19 related symptoms, or even in the combinations of symptoms. And lastly, the CDC wallet, or CDC software, can also perform query to RRDB in the SDNC and analyze the dynamically behavior of the people under monitoring. SDNC, or the Software Defined Networking Controller, will provide a platform for BIoT nodes, CDCs, and smartphone users. And SDNC handles two types of database, as we represent SADB and RRDB. Because SADB and SDNC is associated with that in the CDC, two calculations to generate DH key in CDC and SDC will produce identical results. It is RR in RRDB that tracks the movement status of each person under monitoring. So the field of ID here will keep encrypted in RRDB with a DH secret key parameters for the individual. So basically, if we going to summarize the task performed by the SDNC, so it will include the following. First, it will maintain SADB entries generated as a result of the prime value table that we generated in exchange procedures initiated by the CDC. At the same time, it will also calculate the DH key using the SA, which the field value of BOIT node ID points out, to encrypt sensitive information in our resource record. Third, it also maintains RRDB entries and updates them when the update RR message arrive from our VoIP nodes. And lastly, it will send the corresponding RRs match after receiving queries from the CDC and normal users in response. So this is to sum up the third part of this paper. So next time we will continue the other part of the paper. Thank you.